Okay, guys, today is a video on acid deposition, and then you have a little pre-lab, so I will give you instructions for the pre-lab at the very end. So we're just going to do a really fresh, really quick reminder. So remember that air pollution is the introduction of chemicals, particulate matter, or microorganisms into the atmosphere at concentrations high enough to harm plants, animals, and materials such as buildings or to alter ecosystems. And I think we already wrote this definition down on your chart. Let's do a really quick review. Remember that the atmosphere has several layers, and they are the troposphere, stratosphere, mesosphere, thermosphere. You can remember it as these spheres mask and then the last one is exosphere. And so we can say Earth. And so we're concerned right here, down here at the bottom of the troposphere. Okay. And so here we have the most amount of pressure because it's the densest. Here we see that temperature is going to change as we move through the atmosphere, but that my pressure is the highest here because I have the most molecules. So air pollutants can be natural. They can be found from dust. And so in fact, sometimes if you see really beautiful sunsets, specifically in places like Texas, some of that is due from dust that blows over from the Sahara. It could be from wildfires or volcanic eruptions or organic compounds released by plants. Most of what we're going to be talking about are human sources that come from power plants and industrial factories, mining, and then motor vehicles. So remember that primary pollutants are things that are emitted directly into the atmosphere. So primary pollutants are things that are released directly into the air. Examples include carbon monoxide from generators or cars, carbon dioxide from cars, SO2, this comes from the burning of coal, NO, NO2, and N2O, this comes from cars. Methane is going to come from volcanoes and fracking. And then suspended particles from things like mining. So the big ones that we need to know are these NOx's, NOxes, those come from cars. CO2 comes from the burning of fossil fuels. SO2 comes specifically from coal. When they react with things that are in the air, we call them secondary pollutants. And so that's specifically what we're talking about today. We're talking about secondary pollutants. So here's a little list that you should basically commit to memory. I know we already have a chart, but here we have particulate matter. This isn't solid. This comes from the lead used to come from gasoline, but now that's been phased out. Sulfuric acid can be a droplet. NOx comes from cars. SO2 comes from burning of coal. And then CO and CO2 come from combustion, incomplete combustion. Methane from fracking. And then ozone is the big one that's secondary, and we're going to talk about that later next week. Okay, so really fast, particulate matter are just droplets that go into the air. This is soot. This is lead from, it used to be in gasoline. Now we find it sometimes in paints and in piping. It's mostly been phased out. And asbestos, we talked about, these are toxic. They can be carcinogenic. Carcinogenic is when something causes cancer. So NOxes are really important. This is comes from motor vehicles and from fossil fuel combustion. It irritates the respiratory tract. It's going to lead to ozone, and it's going to cause nitric acid. And that's what we want to talk today about. SOxes come from the burning of coal, and this is also going to cause acid precipitation, and we're going to hear about that today. Okay, so I'm going to skip through the rest of this. And so what we've seen is that over time, these 6 major air pollutants have decreased over time. So if we had to make a claim, we would say that the amount of air pollution has decreased from the 1970s to 2006. Here you can see the percent change, and that's due to the Clean Air Act. Remember that the Clean Air Act regulated nose clip. NOxes, O stands for ozone. S for SO2, C for carbon monoxide, L for lead, and P for particulate matter. And so this decline has been due to especially here you see in lead, has been due to the Clean Air Act. So I want to talk mostly today about acid deposition. So acid deposition, or acid rain, is the formation of acid from the atmosphere, and it falls onto the Earth's surface. It can be in a liquid form, or it could be what we call acid deposition, in which that's the dry. So like pieces of dust that are acidic fall to the ground. And remember that acid rain comes from SO2 and NO2 from the NOxes and the SOxes when they react with water in the atmosphere. And they're going to give us something that's acidic. Remember that the pH scale runs 0 to 14. Anything 7 or less is an acid, anything that's 7 or higher is a base. And so most of the time, water is, or I mean, like rain is naturally acidic. It's sitting somewhere here in the 6-ish range. Anytime it falls kind of below that and into this weak acid or strong acid area, we're going to call that acid deposition. And so here's what the formulas that you need to have memorized. So SO2, remember this comes from coal, and NOxes, this comes from fossil fuels, specifically cars, react with oxygen and water, and I get out this sulfuric acid, H2SO4, and H3NO3. You do not need to know these other things that are here, but what you do need to know, and I'm going to annotate on the screen, hopefully. I need you to know this. I'm looking for how to change the color. This is what I need you to know. That this SO2 reacts with oxygen to create sulfuric acid. NOx plus oxygen is going to create nitric acid. Okay, so this is what we need to know. This is a formula that you need to have committed to memory. Okay, don't worry so much about this acid deposition, but SO2 plus O2 or SO2 plus H2O yields sulfuric acid, H2SO4, and NOxes plus oxygen or water gives me nitric acid, HNO3. You don't need to know the chemistry behind it. You just need to know that when they react, I'm going to get out this sulfuric acid and nitric acid, and that's what you guys know as acid rain. Okay. Oops. So here you can see acid rain is mostly a concern here in New England, although it does spread west. You see it forms majorly around major cities. And that has to do with the fact that you can't, just because it's released, say in a city, the wind patterns carry it. So we can't keep it isolated. And you just mainly see it's here a concern in New England. It used to be a greater concern, although we've limited it. Also a concern here in Canada, mainly coming from production in the United States. So what are the impacts of acid deposition? This causes the nutrients to be leached from the topsoil. If you remember, let me see if I have a picture. Here we go. So if you remember, oops, sorry, I'm gonna kind of go back. So if you remember that the soil has 3 particles, sand, silt, and clay, that clay is negatively charged, and that's what holds on to the holds on to metals and holds on to nutrients. When the acid rain comes in, the clay releases these metals and it would hold on to the acid. Remember that acid is positively charged. So when you have acid rain enter into the soil, the clay releases the metals and holds on to that positively charged acid instead. And therefore, these metal ions can now wash off and pollute the water. It also causes these nutrients to be leached or lost from the topsoil because that clay isn't holding on to them. This causes trees to die. Acid, if it's acidic, gets into the surface water. That's bad for the fish. Damages agricultural crops, also erodes away buildings and cars. And so what we see is, here's a picture. We can see this acid deposition damages leaves and barks, reduces photosynthesis, causes a decline in the trees. Soil becomes acidic. This can damage any of the nutrients. The soil nutrients are lost. And so that ultimately we call this general forest decline, and that has to do with acid rain. So one way to fix this would be to just add a base, such as lime, to the soil. Some areas like in Texas and here in Colorado, we have a more basic soil. That's because we sit on limestone beds, and that naturally helps buffer or helps reduce some of the impacts of acid rain. So if you have a pond that has become acidic due to acid rain, I want to add a base such as lime. Some of them in parts of Texas and parts of here in the Western United States have naturally more basic soil due to the parent material that it's made of, and that helps buffer or help reduce in the impacts of acid deposition. Okay. And just this is all I was talking about here, was just that we can't keep acid rain in one location due to wind patterns. It moves around a lot. What can we do? Well, we can use two pieces of technology. Here's electrostatic precipitators. Electrostatic precipitators work really well to this dirty smoke from the burning of fossil fuels and coal goes in. There's negatively charged electrodes, and this takes out the particulate matter. Wet scrubbers are very similar. They go in, this dirty gas goes in, and they remove SO2. So these are two pieces of technology that we can use to try to reduce acid rain and reduce particulate matter, and you need to know them, that an electrostatic precipitator is going to take out particulate matter and a scrubber takes out SO2. Okay, so obviously, best would be just best options are prevention. We're going to walk, use improve fuel efficiency, use a bike, take mass transportation, and then get older cars off the roads, reducing emissions, inspecting car exhaust. So that's part of the reason why you have to have, in some states, like in Texas, you have to have your car, your system is checked every year in order to get your license and registration. Other things we can do is add technology like electrostatic precipitators and scrubbers. And so the best way is just to prevent it and to reduce our use of fossil fuels altogether. So hopefully this was helpful. We will review some of this in class. If we take a look at your activity today, all you need to do is you're going to do the pre-lab activity. So you're going to create a graph that shows the concentrations over time. So on my x-axis, you're going to put time. On the y-axis, you're going to put concentration. And so I would like you to graph this NO2, NO3, and SO2. That can be one x-axis. If you want to make a separate graph with pH, you can. If you want to make a second y-axis on the right-hand side and graph pH, you can do that. So I want you to create a graph showing NO3 and SO4 over time, pH over time, and then I want you to calculate the rate of change. All you're going to do is to calculate the rate of change, you're going to take the final value minus the initial value divided by how many years you have. So I want to see a change in concentration for SO4 and NO3. Reach out or text me or hit me on the Remind app if you have any questions. I will be available by email all day. I hope you guys have a great day.